Simplifying algebraic expressions is one of the most common tasks that we have in college algebra. So it's crucial for us to learn these rules and learn how to implement them effectively. All right, the first rule we're going to take a look at is called the product rule of exponents. Suppose I have an expression x squared times x to the fourth. We can expand this out to look like this. In red, I have x times x, that's x squared, and then in blue, I have x being multiplied by itself 4 times. This whole thing collapses down just to x to the sixth. X is being multiplied by itself 6 times. So I have x to the sixth, but notice that 6 is the sum of 2 and 4. So we have x squared times x to the fourth equals x to the 2 plus 4. So when we have the same base being multiplied together with two different powers, this rule says that we can condense the base into one and raise it to the sum of the powers. We can generalize this for any numbers m and n. For any real number x and any integers m and n, we have x to the m times x to the n is equal to x to the m plus n. The next rule is called the quotient rule of exponents. If I have the expression x to the 5 over x to the 3, we can expand this out. Up top, we have x being multiplied by itself 5 times, and on the bottom, we have x being multiplied by itself 3 times. So we can see that some of this stuff is going to cancel, right? We have 3 x's up top and 3 x's on the bottom. So those cancel, and it leaves us with 1 in the denominator and 2 x's up in the numerator. So this whole thing just equals x squared. So we have x to the fifth over x to the 3 equals x squared. But notice that 2 is the difference of 5 and 3. So we can subtract 5 and 3 and get our new exponent. All right, we can generalize this for any numbers m and n. X to the m over x to the n is equal to x to the m minus n. So this is what the quotient rule says. The power rule is when we have a situation like this, when we have a power on top of a power. X squared, that whole thing is being raised to the third power. So this business in red here, it's being multiplied by itself 3 times. That's what cubing means. We multiply it by itself 3 times. So we can expand this out a little bit, and we have x times x times x times x times x times x. And we can get rid of the unnecessary parentheses, and we can see that we have x being multiplied by itself 6 times. So we have x squared, whole thing cubed, equals x to the 6. But notice that 6 is the product of 2 and 3. All right, x squared, whole thing to the third power, equals x to the 2 times 3. Once again, we want to generalize this for any powers m and n. For any real number x and any integers m and n, we have x to the m whole thing to the nth power equals x to the m times n. The zero exponent rule is pretty interesting. Suppose I have the expression x to the fifth over x to the fifth. Now we know that that cancels and gives us 1. But I want to look at x to the fifth over x to the fifth in a different way. Remember, the quotient rule says that if we have the same base on the top and bottom being raised to some powers, we can take that base and raise it to the difference of the powers. So this equals x to the 5 minus 5, which equals x to the 0. So I have this thing here, x to the fifth over x to the fifth, it equals 1, but x to the fifth over x to the fifth also equals x to the 0. So if a equals b and a equals c, we can set b equal to c. So x to the 0 equals 1. For any non-zero number x, we have x to the 0 equals 1. The negative rule of exponents is also interesting. So if we have x to the 3 over x to the 5, we can expand that out like this. We have 3 x's up top and 5 x's on the bottom. Some of this stuff cancels, right? We have 3 x's canceling with 3 x's on the bottom, and we have 1 over x times x left. And that is the same thing as 1 over x squared. Okay? But let's take a look at this a different way. X to the 3 over x to the 5, right? I have the same base to 2 powers, right? So the quotient rule says that I can subtract those powers. All right? So this equals x to the 3 minus 5, which is x to the negative 2. So here, once again, notice that x to the 3 over x to the 5 equals this. But down here, it also equals this, x to the negative 2. So if a equals b and a equals c, then b equals c. So this is the result that we have. X to the negative 2 equals 1 over x squared. When we have a negative exponent, oftentimes we're asked to report our answer with only positive exponents. So we can generalize this and say for any non-zero real number x and natural number n, we have x to the negative n equals 1 over x to the positive n. We can also show that 1 over x to the negative m equals x to the m. So this is how you can switch back and forth between positive and negative exponents. We're going to use this rule a lot when we clean up our expressions. The power of a product rule. Okay, here I have xy whole thing to the 3. All right, so we can expand this out. This thing in blue is being multiplied by itself 3 times. So we can get rid of the unnecessary parentheses, and then we're going to use the commutative property of multiplication to rewrite this expression like this. That commutative property says that it doesn't matter what order we multiply in. So here I have x cubed, and here I have y cubed. So we have xy whole thing cubed equals x cubed y cubed. The power 3 is being applied to each piece of the product. That's the way I like to look at it. And we can generalize this for any power n and simply apply that power n to each piece of the product to get rid of the parentheses. Okay? The next rule is very similar. The power of a quotient rule. Here I have x over y to the 3rd power. So this thing in blue is being multiplied by itself 3 times. We can get rid of the parentheses, and here we have some fraction multiplication happening. So whenever we have that, we need to multiply the business in the numerator and multiply the business in the denominator. This gives us x cubed over y cubed. So the power 3 is being applied to the numerator, and it's also being applied to the denominator. We can generalize this for any power n, and we can say for any real numbers x and y and any natural number n, we have x over y whole thing to the nth power equals x to the n over y to the n.